Have you ever peeked at a kid's math homework and just thought, what is this? This looks nothing like how I learned it. Well, if you have, you are definitely not alone. Today, we're going to dive into why math class has changed so much, moving from just memorizing rules to a whole different way of thinking. And it's not just parents who are scratching their heads. This question from a Reddit user really gets to the heart of a frustration that, let's be honest, a lot of us have felt. It's that nagging feeling that we're just, repeating formulas without ever really getting it. This has been the big puzzle in math education for ages. Is there a better way to learn this stuff than just memorizing a bunch of rules? Well, let's dig in and find out. Okay, so to really get this, let's start by looking back at the kind of math most of us probably remember and talk about some of its limits. That classic approach, it's all built on something called rote memorization. And a user on Reddit put it perfectly. It's when you can spit out the fact that 3 times 5 equals 15, but you have absolutely no clue why that means 15 divided by 5 has to be 3. You know the what, but you're completely missing the why. And that's the key difference right there. Rote knowledge versus conceptual understanding. Rote knowledge is all about just following a recipe, a set of steps you've memorized. But conceptual understanding, that's when you can actually explain why the recipe works in the first place. And get this, it's not just a problem for little kids. Research shows this stuff follows students all the way to college. You have university students who are still struggling with basic algebra because they only ever memorized the steps in high school without ever understanding the concepts behind them. So what's the fix? Well, the big shift starts with a completely different approach, and it's called active learning. What's so cool about active learning is how it works. It's not just about getting kids to think harder. It's about engaging them on 3 different levels all at once. Intellectually, of course, but also socially and even physically. So what does that even look like in a real classroom? Well, it could be anything from hands-on stuff like folding paper to understand fractions, to these collaborative sessions called gallery walks, or even taking the classroom outside for math trails. I mean, just look at this. You can see the focus is on actually doing things. On one side, you have a student really zeroed in on a paper folding task, a super tangible way to get a feel for geometry. The main idea, whether you're working alone or in a group, is always the same. You learn by doing and by talking about it. Let's break down that gallery walk thing because it's pretty neat. It's a structured 6-step process. Groups solve a problem, put their solution up on a poster, and then, here's the cool part, they walk around and analyze and comment on what other groups did. It completely changes a boring old worksheet problem into this lively social event where you're learning from everyone. Okay, let's talk about the other huge piece of the modern classroom, technology. But its real power isn't what you might think. To make sense of technology's role, a lot of educators use this simple model called the RAT framework. Technology can just replace an old tool, like a worksheet becomes a PDF. No big deal. It can amplify a task, making it faster or more efficient. Or, and this is the real goal, it can transform learning into something that just wasn't possible before. And that transformation, that's where the magic is. We're talking about moving away from one-size-fits-all lessons to something that's customized for each student. It means going from a flat, static picture in a book to a dynamic, interactive model you can play with. And maybe most importantly, it's about shifting the focus from the teacher lecturing at the front of the room to the students really exploring on their own. But, with all these new ideas flying around, it's pretty easy to get carried away. So let's hit pause for a second and look at what the actual evidence says about some popular myths in teaching. All right, here's a big one you hear all the time. The myth is that a student has to completely understand the big idea, the concept, before they can learn the steps to actually solve the problem. But it turns out the research says that's just not quite right. The truth is, it's a two-way street. Learning the steps can actually help you understand the concept, and understanding the concept makes it easier to remember the steps. They help each other out. They build on each other. Okay, here's another super popular idea, productive struggle. This is the belief that the best way for students to learn is to just let them wrestle with a really hard problem all by themselves. But what do we really mean by struggle? I love this quote from a couple of experts, Heber and Grouse. They make it clear that true struggle is about putting in the effort to make sense of something. It's not about needless frustration or being faced with a challenge that's just impossible. There's a really important difference. So here's the bottom line from the research. While effort is absolutely crucial, For students who are brand new to a topic, just letting them loose with unguided discovery often leads straight to that needless frustration. For a beginner, clear, direct instruction from a teacher is often way more effective. So, if we pull all of this together, what does it even mean to be good at math anymore? I absolutely love this analogy from Reddit because it just nails the balance we've been talking about. Math is like basketball. You 100% need to do the drills, that's your basic skills. But to really get good, you have to actually get in the game and play, and that's using your understanding to solve real problems.
So what can all of us take away from this? A few things. First, always ask why a formula works, not just that it works. Second, try to visualize the problem. Seriously, draw a picture. It helps. And third, a fantastic way to test if you really get something is to try and explain it to someone else. If you can't, you probably don't understand it as deeply as you think you do.
And that kind of brings us to the big final question. What if we've been measuring the wrong thing this whole time? What if being good at math has nothing to do with how fast you can find an answer, and everything to do with how curious you are to understand the question in the first place? Something to think about. Thanks for tuning in.